In yesterday's lesson, we talked about the sum of square and square of the sum. For today's lesson, we are going to discuss the sum of the cube and the square of the sum. So it's well known that the square of the sum is equals to the sum of the cube. Example, it is equals to 3 square, that is 9. And 9 can be written as 1 plus 8, that is 1 cube plus 2 cube. 1 plus 2 plus 3 square is equals to 36. And is equals to 1 plus 8 plus 27, that is 1 cube plus 2 cube plus 3 cube. And there are some visualized proof available online. We try to extend this result by a bit by considering an operator. That is, given any positive integer n, let's say 12, then we list out all the possible positive factors. That is 1, 2, 3, 4, 6, and 12. There are 1, 2, 3, 4, 5, 6. We can always check it again because this 12 is equals to 2 square times 3 to the power of 1. So the number of positive factors should be equal to 3 times 2, that is 6. That's good. So this is the factors of 12. The next level, you'll get for each of the number, you want to find only the number of factors. The number of factors of 1, it is equals to 1. The number of factors of 2 is equals to 1 and 2, that is 2. The number of factor of 3 is 1 and 3, that is 2 again. The number of factors of 4 is 1, 2, and 4, that is equals to 3. And for 6 is 1, 2, 3, 6, that is 4. And 12 is 1, 2, 3, 4, 5, 6. Okay. After these two operations, then we claim that this number will have the similar property that the number that we have here. That is, the square of the sum equals to the sum of the cube. Let's check it. So if we take the sum and square it, it will be equals to 18 square, that is 324. And the sum of the cube will be equals to 1 cube, 2 cube, 2 cube, 3 cube, 4 cube, and 6 cube. This is 1 and 8, 8, 27, 64, and 216. After a bit of calculation, you'll see that this is 324. And this is true not only for this number 12, true for any positive integer n. So the operation is list out all the possible positive factors of this number n. And after that, for each of the factor, we need to find what is the number of the factors. Okay, and whatever that we have, we'll get the number is good as saying the square of the sum equals to the sum of the cube. We also see that this operation also will give us the original result. That is, we choose a power of the prime number. Let's say 5 to the power of 3. Then the factor of 5 to the power of 3 should be 1, 5, 5 square, and 5 to the power of 3. The number of factor of 1 is 1. The number of 5 is equal to 1 and 5, that is 2. 5 squared is 3 factors. 5 to the power of 3 should be a 4 factor. And with this, then we see that if this is a prime number to the power of n minus 1, then we got back to this original result. Now we should illustrate a little bit why this is true. Now note that 1 plus 2 plus 2 plus 3 plus 4 plus 6 can be factorized as 1 plus 2 plus 3 and 1 plus 2. Let us try to expand this. We have 1, 2, 2, 4, 3, and 6. Everything here. So if we square this, then we need to square everything here. And this should give me 1 plus 2 plus 3 squared. And this 1 plus 2 squared. And from the previous result that we already know, this should be equal to 1 cube plus 2 cube plus 3 cube. And this is 1 cube plus 2 cube. And therefore, we can expand it again by multiplication, this will be 1 and 1 cube is 1 cube. 1 cube and 2 cube, it will be 2 cube. 2 cube and 1 cube will be 2 cube. 2 cube and 2 cube, that is 4 cube. 3 cube and 1 cube is 3 cube. And 3 cube and 2 cube is 6 cube. Then we just prove that the square of the sum equals the sum of the cube. The numbers that fulfill square of sum equals to sum of cube not necessarily come from this operation. For example, so 4 plus 4 plus 4 plus 4 square. That is equals to a 16 square, 256. Now, if you take 4 power 3, 4 power 3, 4 power 3, 4 power 3. Each of these will equal to 64. 64 times 4 is also equal to 256. From here, we can have a trivial result, say that if ak is equal to n for all k equals to 1 to n, then the square of sum will be equal to sum of cube. And it's not difficult to prove this result. There are more properties that can be found for this type of number. You may refer to the sum of the reference that I put in the description. That's all for today's lesson. I hope you enjoyed it, and I will see you next time. Bye bye.